Every time you close a standard AI chat window, its entire understanding of you vanishes. Modern models treat new interactions as if you've never spoken. For anyone trying to do serious work, this creates immediate friction. You end up in a repetitive loop, constantly repasting the same background context, explaining your project history, and losing track of decisions you made with the AI just 3 days ago. The next major leap in artificial intelligence will not come from adding a few billion more parameters to a base model. It will come from the creation of a durable, persistent memory layer for the AI to inhabit. A system without memory remains trapped as a reactive assistant. It cannot become an autonomous operator if it cannot store information and update its own context over time. To fix this, developers are piecing together a new type of stack. Right now, a specific pairing is gaining heavy traction, connecting a local Markdown-based note application directly to a system-level AI agent. Obsidian and OpenClaw represent two distinct halves of a locally hosted computing architecture. This interface reveals the difference. On the left, a desktop view maps out interconnected nodes of thought. On the right, a synchronized mobile task list. This is a permanent, searchable network of ideas, rather than a temporary chat interface. By giving the AI a physical, navigable place to live and recall information, this combination provides a structural fix for context decay. The foundation of this system is Obsidian. It operates as a local-first environment built entirely on plain text Markdown. Because these are simple text files stored on your hard drive, your data remains accessible decades from now without relying on proprietary servers. This image demonstrates how the internal architecture works. On the left, a text link is typed into a document, and on the right, that link instantly generates a visible structural node in the knowledge graph. Isolated files become a readable network. The software scales into complex planning. Here, we see the Canvas interface for mapping ideas spatially, right next to a menu of plugins that add structural tools like Kanban boards and advanced beta queries to your text files. Because Obsidian relies entirely on these local linked text files, it is the lowest friction environment you can provide for a machine to read, index, and organize. The other half of the equation is OpenClaw. As the branding here clearly states, this is an AI built to execute tasks. Instead of living inside a single browser tab, it is an agent designed to act directly across your operating system and existing chat apps. These capability tiles outline its specific mechanics. The system has direct shell access to run scripts, the ability to read and write your personal files, and native controls to operate your web browser. Because it can touch your files, security is critical. This feature list highlights the local-first privacy requirement. To prevent sensitive vault data from leaking, the execution and data sovereignty stay entirely on your local machine. Providing direct terminal and file system access transforms the AI. It shifts from a passive text generator into an active digital operator. The actual workflow operates in a four-step loop. First, the user asks a question. The AI then uses semantic search, parsing your local vault for actual meaning, not just exact keyword matches, to extract the right context. The loop closes when the AI synthesizes that extracted history and physically writes its conclusion back into your Obsidian folder as a brand new, correctly linked text file. Looking at this use case panel, we see exactly how you apply this. Under Research Retrieval, you can query the AI to sift through hundreds of scattered personal notes and return a single synthesized answer. It also automates daily friction. You can command the agent to generate structured meeting notes, correctly format them, and append them directly to your daily log, all without opening the Obsidian app yourself. Moving to content creation, you can ask the system to draft a comprehensive blog post or project outline. Because it is drawing from your vault, it relies entirely on your own verified facts and previous ideas. This continuous loop creates a different kind of workflow, one where an AI actively updates and expands its own memory base as it works. We need to be clear about the current limitations. A persistent vault improves context, but the base models can still misinterpret data or generate hallucinations. The logic is not flawless. There are also technical hurdles. Running semantic indexing across thousands of files requires significant local compute power. And if you use third-party tools to sync your vault across devices, you can still run into version conflicts. Finally, the human bottleneck remains. The garbage in, garbage out rule applies. An AI cannot extract a coherent, structured output from a vault that lacks basic organization. Giving an AI mechanical access to a file directory is simple. Cultivating and maintaining a useful memory layer takes discipline. We are moving past the era of ephemeral chat windows. The market is shifting toward comprehensive, durable workspaces where the AI is integrated into the environment itself. This integration header captures the end goal, giving your second brain AI capabilities. A monthly cloud subscription cannot compete with the compounding value of a locally owned, permanent knowledge graph. Over the next decade, your competitive advantage won't come from having access to the smartest language model. It will come from the quality of the private, durable memory graph you build for that AI to operate within.